Today's speakers are coming from the Kessel Run cost team, sharing their experience in standing up a software factory, including some hidden costs that were discovered as they went. Please welcome Stephanie Quintal, Kristen Marquette, and Burke. Ladies.
Thank you. Good afternoon, everybody. My name is Stephanie Quintal, and I am the Deputy Cost Chief for Det 12. With me today, I have Ms. Kristen Marquette and Ms. Burke, both are cost estimators in the Det 12 portfolio. I wanted to start off today by thanking the ICEA staff for having us today, especially Megan and Kristen for giving this opportunity. Although we are not in San Antonio, we're still super fortunate to be able to share our brief and do this today. So without further ado, next slide. Okay, so today's agenda, to start, we are going to do a Kessel Run software factory overview. That will include an introduction to Kessel Run, who we are and what we do. We're going to dive into some Kessel Run results. Then we'll get into some software factory manpower to include product teams and support teams. We'll get into some systems engineering, product management support, some acquisitions and leadership analysis support. We'll get into travel and training, wrap it up with software and environment, and then we will go through some challenges we've had and some conclusion slide. Okay, so in 2016, Kessel Run proved not only that software acquisition could be done differently, but that development could be done in-house faster than ever. It proved a model where development team frequently delivers new capabilities under a continuous authority to operate, or an ATO, within the air operations world. So today I'm going to start with our Kessel Run vision, which is to deliver combat capability that can sense and respond to conflict in any domain, anytime, and anywhere. Next slide. Here we have our Kessel Run mission, which is to continuously deliver war-winning software the warfighters love. Something to note here is the continuously word, and that is important in our model. So at this point, most of us have probably heard terms like software factory, and some of us may have been asked to create a cost estimate for software development. So I think that it's important to go through Kessel Run, how we have a relationship with our stakeholders, and what we do in the Kessel Run that's different than our typical software development. So I'm going to start by doing an overview of Kessel Run, the processes, and the relationship between stakeholders. So on the left, we have our relationship with ACC in the gray. So our relationship with ACC goes through this gray portion, and then we get into the pink portion, which is Kessel Run today, and we've had a lot of lessons learned. We're still learning lessons in this pink portion. So below the wave is our traditional mapping to the traditional requirements process. You can see that I've highlighted the JSIDs and the PPVE and how that maps to our model. So we're going to start with the gray. So on the gray side, we are changing our traditional contractor shall statements to more goal statements, and that wraps in what our value stream mapping and impact mapping is. We move through the gray and we get to our first triangle. So what that triangle here is, it represents a growth board. And what a growth board is it's a decision point in which the team decides if product is still bringing value to our customer. These growth boards are done at the product team level, done at like PM and designer level. And the team itself decides if the product is still bringing capability to the warfighter, or if it can be shelved and possibly brought back or completed for that capability. So once we get into the pink portion, we see we have product scoping, discovery and framing, and inception. So each of those are separated by that growth board. So as we move through this pink wave, the team is deciding, are we still bringing value to the user, or is it time to shelf this capability? So something I want to note here is the discovery and framing mapped to our traditional risk reduction. And how that works is the discovery and framing is a 4 to 6 week process where the team sits down and they are discovering pain points and framing solution for those pain points. No actual software development, no coding is done in this block of time. The team is just discovering pain points and how they can overcome these pain points. So after these 3 steps, we get to that final growth board, that 4th triangle that Kristen is circling. That's called our MVP, minimal viable product. I'm gonna let Kate talk about that, but that's basically our first push to the user. And then after that's pushed, that MVP is pushed, the user is able to provide us feedback. So it goes through this continuous iteration where the product goes from testable to useful to usable to useful and finally joyful. After that MVP, the user, like I said, is able to provide feedback, and the feedback gets that product from maybe something that they can start to use to finally something that they actually wanted. The fastest time of a non-Kessel Run team to go through the Kessel Run is 57 days. That's a shout out to Section 31 in Los Angeles. And you can see that timeline on top it's pushing that time from what could have been years to weeks, hours, and days. Next slide. I'm going to pass it to Kate to talk through the MVP.
Great, thank you, Steph. Okay, so the first question that we need to ask is, how do we actually become agile? And the answer is we have to experiment, and we have to shorten the timeline of this build, measure, learn loop that you see here so that we can continually burn down the risk of building something that doesn't work, isn't secure, or just simply doesn't meet the needs of our user anymore. If you take a look at the top depiction on the left, we see the traditional method of development and acquisitions. So here, the focus is on building an entire perfect product for the user in one go, that joyful state that Steph mentioned. The problem is this leaves the user dissatisfied until that project is actually completed. This often takes years, as I'm sure some of you have known or either experienced. Not to mention, the product could be antiquated or irrelevant by the time it's even delivered to the warfighter in the field, and the focus shifted instead to another higher priority need. The bottom depiction on the right illustrates the Agile development method by contrast. The first goal here is getting something usable out to the field. Not perfect, but usable. So this is that minimum viable product, or MVP, that Steph talked about a little bit. It may not tick every box on the list, but it is enough to solve, or a step towards solving, the biggest issue that the field is experiencing currently. Once that issue is taken care of, then focus shifts to the next biggest issue, and so on until the warfighter ends up at that joyful solution. Just like you can see in that top left corner, the skateboard is not going to keep you dry in the rain, but it is faster than your own 2 feet. The bicycle is going to be a little bit faster still, improving the mode of transportation each time through the loop. Each iteration only burns a fraction of the risk that would build up over time with traditional waterfall methodology. Bottom line, with this process, there's actually less time between deliverable products, the interface with the user is way more frequent, and we can get through this cycle faster. Next slide, please. Okay, so we touched on the first two, lean product development and user-centered design, a little bit already. So let's take a look at that last piece, that extreme programming. This is comprised of 2 different portions. First, we have our paired programming. And this is a practice where we have 2 software engineers developing production code sitting at the same machine. So the benefit here is that we can have higher quality software when 2 developers are actively reviewing the code together, discussing it, making more sound technical decisions, things like that. You'll see this reflected in our cost model when Kristen talks to our FTE breakdown. The next part of extreme programming is test-driven development. And this is a practice where we write test code first before we actually write our code that goes into production. Once the test passes, we review the code, refactor it, clean it up, so that it's really readable and very, very simple. By practicing TDD, we choose to see our code as always in draft, meaning code can always be improved and is never permanent. This follows along with the Kessel Run mantra we have of software is never done. As we write our tests to kind of assert these correct behaviors of our applications, we build our new production code upon each successfully passed test. Next slide. Okay, I know there's a lot of information on this slide. There are a couple things that I do want to highlight real quick before we move on. And the reason we wanted to include this slide is because it is one of the ones that we do update pretty continuously with our most recent statistics. And the first thing I want to talk about is this 42 balanced teams in that top left corner. And again, Kristen's going to talk to the FTE breakdown in a few slides, but it is really important to recognize that we do have balanced teams. And I want you to remember that as we click through. The next thing I want to talk about here is the shortened time to produce MVPs, those minimum viable products. So here you can see that's 124 days, which is just over 4 months, which is pretty remarkable timeline, especially in the eyes of the warfighter who is counting on these products to be pushed out to them in a timely manner so that they can get their mission done in a appropriate timeline. And actually, once they solve that issue, then they can move on to something that is pressing afterwards. So that 124 days to MVP, that 4 months is very important, and we're very proud of that. Next slide. Okay, I'm not going to quote FAR parts to all of you. I'm sure you get enough of that. But the main thing that I want to highlight here is our acquisition strategy when it comes down to our contracts. We are working with multiple types of contracts for different scopes of work in order to tailor them more to our needs here at Kessel Run. Instead of longer contracts, we found that using shorter contracts with many 6 to 12 month option periods is actually more beneficial for our model. This coincides with our fail fast ideology. So if something isn't working or it's just not working well enough, then these shorter contracts with shorter option periods gives us the flexibility that we need to scrap it sooner and find something else that will. Next slide. Okay, I wanted to leave you guys with this quote. Some of you may have heard it before. It's pretty striking. 94% of federal IT projects are over budget or behind schedule. 40% of those never end up seeing the light of day. I'm sure many of you have been on programs that have been canceled, or they just take so many years, decades and decades, and by the time the product gets pushed out to the warfighter, it's not needed anymore. So that's one thing that we are trying to alleviate with agile methodologies for costing out software and the whole overhaul of a waterfall method, so that these percentages drop way down and that we are a little bit more useful to our users sooner than later. Next slide. Okay, I will pass it to Kristen.
Thanks, Kate. Okay, so first off, I just wanted to go over some of the assumptions before we dive into our cost model. So first assumption is Kessel Run. We used it as an analogy, just so we compiled most of the data from Kessel Run, since that's the program we're most familiar with, and then we use that to build our cost model. So obviously, if you're building out a cost model, it's going to look very different from ours. It's going to be based on requirements, funding, and really what the users need and what your requirements are from your stakeholders. Next assumption is we did not include platform costs. So we just looked at the capabilities that come with the teams and the FTE. So it's mostly a labor-based estimate, which is great. But I know platform cost is something that is a huge topic of interest to a lot of you, and I know that's something of interest to our team. So we are trying to work to include that. Hopefully we can present again or maybe do a white paper in the future. So that's something we're looking forward to. Next assumption is FTE. So we assume that FTE is a full-time equivalent. So they work about 19, 20 hours per year. And then lastly, we assume there's no cost with military personnel. Okay, so now that you have these assumptions, we're going to dive into our cost model. So our model, again, is going to be capability-based. So it's going to be FTE. So about a product team at Kessel Run when we first started was about 6 to 8 FTEs or full-time equivalents. So this has changed a little bit. Most recently, like now, Kessel Run might have a larger team, maybe it's 10 to 12. However, this was really how to start a software factory. So we kind of looked at Kessel Run from the beginning. So we used 8 FTEs as a typical composition. So you have a product manager, a UX designer, 3 software engineers, and 3 software developers. And you can see here that the product manager and the software engineers are both highlighted in blue. That's just to signify that those are going to be mostly government roles. So a product manager is typically military or government, and the 3 software engineers are going to be government roles just because we are trying to have a more organic composition and not rely so much on our contractors. UX designer and the 3 software developers are going to be contracted out just because of their niche set of skills and the things that we're looking for. So we really do have a balanced product team, as you can see here, and I'm going to talk a little bit more about that. So first off, the product manager, they're going to be working with the stakeholders and making sure the stakeholders have their visions, as well as the user's needs and any technical challenges that go along with it. Then you have designers, and they're engaging directly with the user, trying to understand any pain points and trying to generate those solutions. Then you have the software engineer, and they're creating the software and prioritizing to ensure the application is stable, secure, and able to work properly. So you really need to have all 3 of these people working together as a team. So the product manager needs to be asking, is this a viable option? Will this help the stakeholders? Will this help satisfy the stakeholders? Will this help the business? Then you have designers saying, will the users actually like this? Or if this application is deployed into the field, will users actually use this, or are they just going to go back to the old way of doing things? Then you have the engineers asking, is this actually possible to build? Can we actually do this? And you really need to have all 3 of them working together asking these questions to have one successful product. So it's something that we really focus on at Kessel Run, and it really helps our teams be successful. So now that you have an idea of what a product team looks like, I'm going to move into enablement. So we have one product team, and then alongside that product team, you have an enablement support. So enablement is just a temporary solution. So they're a temporary help. They temporarily help each product team support product development by working alongside the product teams to teach them agile development methods to develop software rapidly and securely. So again, we used Kessel Run as an analogy. So we looked at enablement support, which we use Pivotal at Kessel Run. So this is based on how Pivotal works with our Kessel Run teams. So typically you have a product manager, 1 designer, and 3 engineers. So you're going to have about 5 people per product team. So you'll have those 5 people for each of our product teams, and the 3 engineers are going to be working alongside the 3 government engineers on the product team. So like I said earlier, those 3 engineers on the product team are going to be government roles. So we really need enablement, the 3 engineers on the enablement side, to work one-on-one with each of the engineers, just because we want them to learn new agile development methods, and we want them to learn different ways of maybe helping software go faster, or different methods of even solving a problem. So this is the paired programming that Kate kind of mentioned earlier. And this happens for a variety of ways. So you're going to have the 3 engineers working together, the designer and the product team, just for one product team. And then the director of enablement is going to work across all of enablement support. So they'll oversee all of enablement. So it'll just be one of those. Okay, and then I'm going to go into phasing. So now that you understand that there's enablement in the cost model as well as the product teams, we're going to talk a little bit about how it's phased in the estimate. So for a product team, you're going to start with about 8 product teams per year. And then we said add 6 more teams for the following year. And again, this does vary based on your requirements and your budget and your funding. So this is just a requirement that we had for Kessel Run. This could obviously vary. Maybe you don't need that many applications. It also depends on the user's needs and the stakeholders. So just things to think about as you go forward creating your own cost model. Enablement support. So we used enablement support based on Kessel Run. So again, Pivotal. We looked at the AirOps branch, and for an average, the AirOps branch had enablement support for an average of 13 months. Again, this is just an average, so it varies. It can go up and down. Some teams need enablement for 12 months. Some teams need enablement for 14 months. And one of our teams, Chainsaw, they had enablement support for about 6 months. Then they didn't need enablement support. And then like a couple months down the road, they needed enablement support again. So that happens all the time just because the teams at Kessel Run, they change all the time. Maybe teams are coming together and merging to create one solution and then separating, or the people on the teams are constantly changing. So maybe you have 3 new engineers on that team, and they need a little bit more help learning the new Agile development methods. So there's a lot of different ways and reasons for this, but we used an average just so you could see what it would look like. Okay, the last part of that is you're gonna have your composite labor rates. So we used a contractor composite labor rate, enablement composite labor rate, and then we used a GS12 and GS13 composite labor rate. So I did mention that the product team has the product manager, and then it also has the engineers. Those are all government positions. So we do have DCAs, which are direct site authorities, FM and the commander LCMC approved civilian overhires. So it does allow Kessel Run to hire civilians directly and have them be a part of the more organic composition here. So now that you guys know kind of a bit about the background in our cost model, I'm going to pass it off to Kate, and she's going to go over the support personnel that we included in our model.
Great, thanks, Kristen. So now that you know all about the product teams and the enablement support, how are you actually going to support those people? We need to talk more about positions than just those ones that fall strictly under the product teams when we're taking a look at how to stand up a software factory. So as previously stated, Kessel Run had 32 teams. This was at the time of our analysis. I know that blue block slide showed you that we're now up to 42. But in order to scale back to that 8 to 14 teams that would be stood up in a new software factory cost model, we took the ratio of FTEs that we see over here at Kessel Run and use that in our new model, which is why these pie charts look very similar. It's not a mistake, I promise you. They are the similar ratios. I do want to say that we are doing constant analysis as we grow in product teams to see what support is needed as Kessel Run grows larger. And the main support roles that we are accounting for here are our data and engineering support, operations support, technical support, and of course, our assistant directors. Next slide. Okay, so data and engineering support. They work with our software developers and data scientists to advise on best practices and develop data pipeline architectures that are capable of handling complex data sets both quickly and securely to put solutions into production. Here, we're looking at a ratio of 1 FTE supporting every 2 product teams here, so that's how you read those little ratios in there. Our operations support are facilitating the evaluation of design and operational effectiveness. For example, over here at Kessel Run, we have many operations SMEs who are supporting the modernization of AOC weapon system 10.1 to block 20, trying to toss that up into the cloud. So these ops SMEs are highly specialized between each software factory. Obviously not every software factory is going to need AOC SMEs, but like I said, this is very highly specialized. So you can really pull support for the exact kind of issues that you're facing and what you really need highly specialized tailored help in. Here we have 1 FTE supporting about 5 product teams. Next slide. Okay, technical support. So these technical advisors test and evaluate new and upgraded systems before they're actually delivered to the warfighter in the field. Not every team is going to be rolling out their products at the exact same time. So 1 FTE is able to support about 3 product teams here. And this role is actually playing into that test-driven development, that TDD concept that I touched upon previously that fell under extreme programming. Assistant directors. Okay, so this role really does everything but the kitchen sink if the kitchen sink were to be coding. They are responsible for a portfolio of 3 to 5 product teams each. They advocate for them, resolve needs to shorten delivery cycles, ensure team health, and try to really deliver user value as fast as possible. So the assistant directors are the people that their product teams count on to engage with both the platform team and security team to clear the path to production, as well as manage the external stakeholders. So over at Kessel Run, one of our major stakeholders is ACC. So the assistant director is really the go-between from the product team to the stakeholders. Again, I just want to note that these positions are supporting the product teams themselves and not the platform. As stated in the assumptions, we're not really diving into the cost of the platform itself, so we decided to leave off platform support personnel for the same reason. But like Kristen also mentioned, this is something that we are actively researching and working on, and it is something that we want to, or should hope to, do a project for in the future. And I will pass it off to Steph to talk a little bit about FTE analysis.
Okay, so now that Kristen has talked about product teams and Kate has gone over support teams, let's take a look at the FTE analysis throughout Det 12. So the next following slides will talk through acquisition support and Sepam costs, but for now, let's just take a look at the FTE analysis for the whole portfolio. So what I've done here is I've split Kessel Run FTEs for modernization versus Kessel Run FTEs for sustainment. So I want to take a moment and just talk about what the difference is here. So on the sustainment portfolio, for example, we have AOC and TNG legacy applications. Some of these include products such as EGPL and TNG. This is just keeping the lights on for those products. When we talk about modernization, these are the product teams that have actually moved over to what we call Block 20. They're actually in software development, and they're in, we're modernizing legacy applications in that portfolio. So here, something important to note is the contractor difference here. So you can see in the sustainment on the right, the contractor makeup is much larger than the modernization makeup. And the reason being is, like Kristen had talked about, we have those DCAs. So what the Kessel Run model is doing is relying more on our civilian workforce and our military workforce for product management and product support and even some development. And that drives down our overall costs, and it will essentially drive down our Sepam costs, which I'll talk about. So you can see that the civilian makeup and the military makeup on the modernization side is much greater than sustainment, because again, we're scaling down those contractors and scaling up with civilians and military. Next slide, please. So let's talk a little bit about acquisition support. So acquisition support exists on all branches of Kessel Run. So what these people are is they are doing acquisition-like activities. So the question that I ask for when looking at a skill mix is this person doing software development, or is this person doing acquisition support for software development? So some of the examples of acquisition labor categories include leadership, contracting, budget, costs, legal advisor, facilities manager, and security manager. So for example, Kristen, Kate, and myself, we're cost. We are doing acquisition support. We don't actually do any software development. We are just doing acquisition support for these product teams. So on average, we see that there's about 14.9 acquisition related costs across all branches. So that provides us a percent on top of software development for acquisition support. And what I've done on the left here is I've broken out military, contractor, EPAS, MITRE, and civilian. You can see that although contractor is still a large cost driver for acquisition support, we have 33% civilian, and most of our acquisition support is going to be civilian. Next slide, please. Okay, so now let's dive into some of the Sepam analysis. So again, I started with that question, is this person or skill mix supporting acquisition related costs, or is this person doing actual software development? So if someone is doing actual software development, they fall into this 1,100 people on the top here, that top blue box. Some of the examples of software development labor categories include product manager, program manager, software engineer, software developer, and product designer. So these are those skill mixes that Kristen had talked about when we're talking about software development and those product team makeups. So you can see that I have that 1,100 people that support software development in Det 12. I use that same breakout. So we have modernization on the left and integration and sustainment on the right. You can see that it's about a 50-50 split, which I actually had assumed. But when we look further, you can see that there's actually 100 more contractors on that integration and sustainment branch versus 100 less on the modernization. So when you dive into the numbers, you can actually see that those those 100 extra contractors on the right there are actually being reallocated as civilians, which makes sense in that pie chart, and that, you know, follows with our Kessel Run model that we're going to have more military and more civilian for product management and overhead costs, and essentially that should drive down that Sepam analysis. So let's take a look at that. Next slide. So again, those labor categories include software engineer, product managers, and product designers. So what I did about a year to a year and a half ago is I sent almost like a questionnaire to product managers, program managers, software engineers, and product designers. And I asked them, okay, how much time do you spend doing program management activity versus actual software development? So on this slide, I have it labeled as Sepam costs versus prime mission product, which is actual software development. So on average, we see that the Sepam split for program managers is about 90% versus 10% actual software development. That makes sense. The role of this person is to kind of oversee their portfolio or product and maybe do a little bit of software coding. And then software engineers, you expect those to be the most prime mission product percent, which makes sense. We have a 30-70 split. And then finally, for product designers, we saw about a 50-50 split. So 50% of their time is doing program management related activity versus 50% of their time is actual doing coding. So when we're looking at these these percentages for Sepam to prime mission product split, we can see that in a traditional cost model, we're seeing 56.5% of their time is spent doing prime mission product, and 43.5% is doing Sepam related to Sepam costs. So now when we're looking at the new cost model with less contractors, more civilians, more military supporting code, it's actually driving down our overhead costs. And in turn, we're seeing about 24.1% Sepam related costs for this new effort. So we're seeing about a 20% delta, which is huge. And again, that's because we're relying more on military and more on civilians to do product management and in even some cases coding. Next slide. I will pass it to Kristen to talk through some travel, training, and software environment costs.
Okay, thanks, Steph. So just a couple more things to go over in a cost model and then we'll be done. So first off, I just want to talk over travel and training and how we included that in our cost model. So for travel, we started with government travel, so we assumed that 1 FTE trip per month per product team. And then travel for training, obviously that's dependent on the training requirements, but we assume about a week of travel for training, obviously requirement depending. So I'll talk about training in just a minute so we can kind of get a better idea. And then product team travel, so we assume about 10 FTEs for a 3-month long-term TDY to Kessel Run. And this is just so they can understand the infrastructure, the platform, and how it all works together. We really do think it's important. Well, we didn't include any platform costs in here. It's kind of important to see how Kessel Run works and operates to kind of get a better idea of how the model should be worked out. Okay, so now on to training. So there's a couple workshops that we talk about. So theory of constraints workshop. This is a really important one for Kessel Run, and it's really the idea of problem solving. So it's really, you have a problem that you're like maybe it's in coding or software development, and how you solve that. So there's obviously multiple ways you can solve a problem, and that's true for a lot of things. You don't have to tackle it one way. That might not be necessarily true for math all the time, but in more real worlds, there's multiple ways you can solve a problem. So that's kind of the idea of this workshop. You really work through and see how many ways you can come up with to solve that one constraint. And that's really also the idea behind enablement support. You're really using the enablement support to work alongside the product team and kind of work through problem solving, because there's definitely multiple ways to tackle one problem, especially in coding. There's a couple ways you can go about it. So the idea is to work together and kind of just see different agile methods that can solve the same problem. Value stream mapping is our second training. So value stream mapping is how you get from point A to point B, but it's really how you can get the minimum viable product that Kate talked about. So that skateboard, how you get that skateboard to that car. And you want to map it all the way from point A to B. So how you really get your minimum viable product to a product where the users are really happy. And obviously, you're not going to get there the first iteration or the second iteration, but you'll get there down the road. And it's really just mapping out how you can get there and still get something to the user that's usable. And then we have software coding bootcamp, and that also goes back to the idea of enablement. So you're going to have the paired programming, and that's really like the first couple weeks. You're going to do a software coding bootcamp, kind of learn all the ins and outs of agile development methods, and then kind of seeing what extreme programming and paired programming is all about and why we use it at Kessel Run. So obviously these trainings are Kessel Run specific, and you might have different requirements for trainings or different trainings that pertain to a different software factory. So requirements will definitely vary. So for the software environment, so we're going to go over the cost per seat. So this is start with teams. So product teams, remember I said there's 8 people per product team. And then enablement support, there's 5 people per each product team. So you're going to have 13 people per team. So you're going to need 13 seats. And then this is based on what we said for phasing. So first of all, we said teams, you'll have 1 through 8 teams. So first year, you'll have 8 teams. So 104 seats will be needed based on the 13 seats per team. The second year, you need an additional 6 teams, so 78 seats for that. And then the enablement director is just that one enablement director for everything. And then the support personnel Kate talked about is about 20 people, so you'll need 20 seats. So altogether, you're going to have 203 seats. This is based on our model, it definitely varies. But this is how we basically broke out our software environment. We did a cost per seat model. So Steph always likes to explain this to people as like a gym membership. You pay for your gym membership and everything's included. You have the showers, the gym equipment, everything. So that's kind of like the same thing here. So you pay this fee, but you have your desk, you have your setup, you have your computers, everything's there in front of you. It's just you're paying per seat just to make it a little bit easier. So the cost per seat was $775 in 2018. All right, so now that we did that, I'm going to pass it off to go over challenges.
Okay, perfect. Okay, so some challenges that we have faced and do continue to face. First one, Kessel Run is still fairly new. So at this point, it's about 2.5, 3 years old. So not exactly an infant in the terms of software factories now, since we have so many more that are popping up, but it is still a fairly new program. 2.5, 3 years on any traditional program is still very, very young. So not a lot of data is available. I will say that we have started using a TBM software, and that is technology business management software. And the cost transparency and data fidelity that it's provided to us as analysts, as well as leadership, specifically in terms of decision making, has been absolutely invaluable. So we are working through ways to kind of increase the data that we're getting, figure out the best practices and how to apply that data and analyze it. And on that topic of TBM software, it also was extraordinarily useful to us in actually pulling data for this cost model that we presented on. It tied really easily into the labor reporting tool that we have at Kessel Run, and that allowed us to much more easily pull FTE that are attributed to each of the types of teams that we have, so product teams, enablement teams, support teams, under each portfolio that we have at Kessel Run. So that has been incredibly helpful in sort of alleviating that first challenge. Next one kind of goes along with it. So we are still working out methods to accurately portray this data and keep it up to date. But again, that ties into the next one. So like I said, there are so many software factories across the Air Force and DoD as a whole that are cropping up all over the country. This is amazing, and it will eventually give us more data points to kind of compare our models to and help us sort of baseline and see if what we have over at Kessel Run is the norm, or maybe we're an outlier. We just don't know yet. So once these other software factories sort of start to grow up a little bit more, then it will be really, really beneficial for both us and them to kind of understand the relationship that all the software factories share and where they differ. the last one, which is arguably the most frustrating that we've dealt with so far. I'm sure our budget counterparts will agree with this. There is no appropriation that's strictly designated for software development. I know there was one on the table a couple months back, 6 months back maybe, but I'm pretty sure that got scrapped. I have no idea if there are talks to bring another one back into the DoD, but this is causing some headaches with our contracts. So we do have certain contracts that, depending on how you look at them, they could be classified as 3,400 or they could be classified as 3,600. So there are certain ways that our contracting officers, our PK teams, have to sort of write the contracts to make sure that we aren't breaking any rules, because nobody wants to do that. But also, we have found that in a couple of our contracts, it actually made the most sense to start with one appropriation and then switch to another one. So you really have to, and this goes along with all the tailoring of contracts that I talked about on that far slide, about how we have shorter contracts, many option periods. This is something that you guys really need to have a larger multifunctional conversation about, and kind of decide what is best for your software factory and what kind of contracts are best, how you're best going to use the appropriations that are available to you, as there is, like I said, none for software development at this time. Next slide.
Okay, so in conclusion, this is the methodology we use based on our experience with Kessel Run. This just serves as a template to cost out the standing up of a software factory from inception. So some of the things that we see is the Sepam and acquisition support analysis shows that Kessel Run has different costs than a traditional Air Force software development program. On average, we saw that 15% additional cost in acquisition support and lower Sepam percentages across all branches depending on the FTE positions. Next slide. So we will wrap it up today with some of the questions you want to ask. Ask yourself, ask your team, ask other functionals. Are you going to ride off of a platform? So again, this cost model assumes that you are riding off of a platform that's already been stood up. Like Kristen and Kate have both mentioned, I know that the Kessel Run cost team, we're a bunch of data nerds and we're looking at the data of the platform, and I know we want to start doing something for costing out a platform, but in this situation, are you going to ride off of an already stood up platform? What is the composition of your product teams? What kind of enablement support will you need? What do those contracts look like? How many product teams can you support? And this will tie into a funding question that I'll go through in a second. How many and what type of support personnel do you need? Where will people sit? Are you going to do a government-owned building? How can you support where these people will actually work? What is your funding structure? Back one. Thank you, Kristen. What is your funding structure? So again, how many product teams can you support, and what is your fixed budget, or what can you afford? What does your budget allow for, since this is a capacity-driven model? Next slide. And with that, we will open it up for questions.
Well, we do indeed have a question. So Richard Mabe, if you're ready, I'm going to unmute your mic. Go ahead.
Yes, thank you very much. I love this. This is great. This answers just a lot of question I had in my mind about what the factory looks like and how would you come up with the basic cost of what the factory is. As I'm looking at it, you can tell me if I'm right or wrong, it looks like it's a fairly fixed team size approach. So that means you have a variable throughput for different types of software, different software products. The question I have in my mind is, how do you measure then the velocity of software types so that you know how much throughput can go through at any time, which is critical to the schedule of getting a product out the door? Do you have adequate people to do surges? Do you slow down the quality, or not the quality, but the reduce the amount of minimal viable product? What do you do to make sure that that velocity doesn't lead to a bow wave that causes delays?
Sure, I can try to answer this, and if Kristen and Kate want to pop in, please feel free to do so. So something that's actually really unique to this model is when I talked about that pink wave and those growth boards. Kristen, if you want to show that chart for me, if you don't mind.
Yeah.
So something that's actually really unique to this is throughout this entire process, all those triangles are representing, like I said, those growth boards. So at that point, a team can say, okay, are we still, providing value to the user, or maybe some other product has more value, or some other product is becoming a priority, and the team can kind of reallocate people and move around resources as needed to make sure that we're working the priority for the warfighter. Does that sort of make sense?
It does.
Just want to add quick. So that's a great question. And I know like Steph already kind of mentioned a little. So with the 6 to 8 FTEs for the product teams, that does vary. So that's just a general idea. And that's what we used when we started Kessel Run, but obviously that definitely has changed since. So some of our product teams today might have more like 12 FTEs, some might have 10, some still might have that enablement support. So that does generate and help with the velocity. So just having additional bodies on the team for the time being. And then as Steph mentioned, some teams will come together and merge to solve one solution, and then they'll break apart and form 2 separate teams, depending on the requirements, the user's needs and the stakeholders' needs as well.
Yep, I was just going to mention that exact thing, Kristen. So we've had instances where one team will be working a product, and then they'll realize that another team over at Kessel Run has already completed maybe 60% of code that would help with the application that this first team is trying to build. So in that instance, the 2 teams will come together, they'll compare what they have, they'll help each other out, and then they'll split off again once their individual products are ready to be pushed out. But there's no reason to sort of duplicate work if we can get around that.
And we've got another question coming in from Bill Barfield. Bill, you're on.
Well done, Caitlin, Stephanie, Kirsten. Interesting how you deliver some factors which are usable, such as the factor of 14.9%, 15% for software development, and a factor of $775 per seat. Those are usable factors, thanks. However, what emphasis does your model include for the expensive out years O&S costs for software? How do you emphasize that expensive out years costing? Can't hear anybody.
Yeah, hi. So this is Kristen. I was actually hoping you could possibly rephrase your question. I'm a bit confused on what you mean by the O&S cost.
You build software, you got to maintain it, either upgrades, fixes, patches, and so forth. That too is an expensive, a long-term cost.
Yep.
I maybe missed it where you included that type of cost or emphasize it in your briefing.
Yes, so that's a good question. So I can talk a little bit about it, and then I'll let Steph and Caitlin also add. So for right now, we do include it in like the team composition. So we're basically just talking about capabilities. So the team will work on an application, develop it, and then they'll also work to sustain it. So Kessel Run's still fairly new. We were stood up in 2018. So we're still in most instances of development. So we don't really have any sustainment quite yet. So this is just really how you stand up a software factory. So this model doesn't really touch upon quite the sustainment part quite yet. I think that would be like a next iteration.
Good point. Thank you.
Well, thank you. Well,
sure.
do
you mind if I? Sorry. Do you mind if I just add one thing there? So, again, this model, it focuses on continuous delivery for software, and like Kristen said, that's definitely something we're looking into. We are just getting data in now for teams that have actually released that MVP, and we're doing that continuous iterations and getting better and better. Once we have the data, that is absolutely something that we'll be looking into, is costs after X amount of time after that MVP. That's something that the cost team is looking into, and we'll have more data in the future.
Well, excellent. If you guys would return to my slide, I'm going to give the audience just another minute while I talk about the upcoming ASEA workshop in May 2021. Your abstracts are due November 3rd. That is 41 days away, according to the internet. If you want to put together a paper like this and have a presentation at the workshop, the way to do it is to get your abstract summary in by November 3rd. We're hoping to hear from a lot of you and get more of these fantastic papers out there in May. And I believe that is, that's a good enough chance to ask questions. You've got all the contact information up on the slide right now. I would like to take a moment to thank Stephanie, Kristen, and Caitlin for their time today and a fantastic presentation. Thanks to everyone for tuning in. We've got another presentation coming up next week, I believe. It was, head on over to the ASEA website to see the presentations that are going to be coming up through October. And we hope you all have a wonderful rest of your day. Stay safe, stay sane, stay healthy, stay well, and be good to each other. Thank you.
Thank you, everybody, for your time.